Imagine if time wasn't the oldest thing in the universe. What if the universe existed before time even started ticking? That question doesn't just bend your brain a little. It folds it neatly into an origami swan and launches it into philosophical orbit. For as long as we've been counting seconds, humans have treated time like the ultimate authority. It's the cosmic manager keeping everything on schedule. Stars are born, galaxies spin, coffee gets cold, all because time keeps yelling, "Move it along." But what if time wasn't always the boss? What if for some unfathomable stretch of something, the universe existed without a ticking clock at all? Good evening, curious minds. I truly hope you will enjoy today's video. Before we begin, leave a comment and tell me where and when you're tuning in. And if you find yourself learning something new as you drift towards sleep, consider subscribing, but only if you enjoy these calm journeys through the universe. Now, let's begin. Our minds instinctively reject that idea. We live inside time like goldfish inside a bowl, unable to imagine the water we're swimming in. Everything we know, memories, plans, stories, relies on one thing happening after another. Without time, you can't even tell a story. Imagine a movie without a timeline. The ending, beginning, and blooper reel all happening at once. That's not a movie. That's chaos with popcorn. But when scientists talk about the beginning of the universe, they keep running into a strange possibility. Maybe time, as we know it, wasn't there to begin with. It's tempting to picture the universe starting like a fireworks show. A bang, a flash, and then the cosmic clock starts ticking. But what if the fireworks were just part of something bigger that had been sitting there all along, quietly existing without the need for a countdown? Asking, what happened before time began, might be like asking, what's north of the North Pole? The question itself might not make sense in the way we think it does. Because if time truly had a beginning, then before that beginning is a concept with nowhere to exist. It's like trying to stand in a place that hasn't been built yet. But humans are persistent rule breakers, even when it comes to the rules of the cosmos. We don't like being told something is unknowable, so physicists, cosmologists, and philosophers have spent decades poking at this idea from every possible angle. Some suggest time is woven into the fabric of the universe, like threads in a cosmic tapestry. And before the weaving began, there simply wasn't any fabric at all. Others propose that time could be an illusion, a convenient trick of the human mind to make sense of change. In that case, the universe might have existed in some timeless state, a kind of eternal now that doesn't need a clock. To wrap your head around that, imagine pausing reality. Everything, atoms, light, space, frozen perfectly. There's no motion, no sequence, no before or after. Just stillness. In that frozen state, time has no job to do. It's like a movie paused on one frame, yet somehow that single frame holds the entire story within it. Maybe, at the universe's deepest level, that's what existence looked like before time started flowing, an infinite stillness waiting to unfold. Of course, this idea feels absurd. Our brains evolved to handle things like running from predators and remembering where we left our shoes, not to comprehend timeless quantum realities. We measure everything with clocks, calendars, and deadlines. To us, the idea that something could be without when sounds like nonsense. But physics is full of nonsense that turned out to be true. Once upon a time, people thought the Earth stood still and everything orbited around us. Now we know we're spinning through space on a rock moving at over 100,000 kilometers per hour, and yet somehow we're still late to meetings. Here's the real kicker. Asking whether the universe is older than time might be the wrong question altogether. It assumes that time is a background stage on which the universe performs. But modern physics hints that time might be part of the performance itself, created by the actors as they move and interact. If that's true, then before there was a universe full of matter and energy, there was no ticking clock because there was nothing for time to measure. Time isn't a container, it's an effect, like the wake behind a moving ship. No movement, no wake, no time. This opens up some wild possibilities. Maybe the universe didn't have a start in the way we imagine, but instead transitioned from a timeless state into a temporal one. Picture a frozen lake beginning to melt. The water starts flowing, and suddenly movement exists. That movement gives meaning to before and after. Similarly, maybe the universe was once an endless stillness that began to ripple, creating time as it went. And that brings us back to the question that breaks the clock. If the universe existed before time, then time isn't the ultimate ruler. It's a subject of the cosmos, not its king. That means everything we understand, history, cause and effect, even aging, might be local phenomena, not universal truths. Somewhere out there, beyond our sense of now, could exist realms or states where time doesn't apply at all. To them, our obsession with counting seconds must look as strange as a fish obsessing over water pressure. So, what if time wasn't first? What if the universe didn't begin in time, but gave birth to it? It's a question that turns science into poetry and forces us to confront the limits of our perception. Because maybe, just maybe, before there was time, there was stillness, silence, and the waiting potential for everything that would ever exist, including time itself. And if that's true, then the universe didn't start the clock. It invented it, just to keep us wondering how late we are to understanding it. For something that bosses the entire universe around, time's resume is surprisingly unimpressive. Sure, it's everywhere, it's relentless, and it never takes a vacation. But when you really look at what time is, it starts to seem less like a cosmic law and more like a byproduct of everything else trying to mind its own business. Time, despite its fame, might not actually do anything. It's just what we call the universe's habit of moving from order to chaos, or, as physicists like to say, entropy. Let's be honest. Entropy sounds like a villain from a bad sci-fi movie, but in truth, it's just nature's way of saying, I prefer messier. Every system in the universe, stars, planets, cups of coffee, slowly drifts from neatness to disorder. Ice cubes melt, stars burn out, your closet becomes an archaeological site of forgotten laundry. And through all that disarray, we experience something we call time passing. So in a way, time Time is the universe's polite term for falling apart gracefully. But before we get too poetic, let's rewind, metaphorically, since actual rewinding doesn't seem to work in our universe. When physicists talk about time, they don't mean the same thing your wristwatch does. Time in physics is a coordinate, like space. Just as you can say you're standing 3 meters north and 2 meters east, you can also say you're existing 10 seconds after something else. Time is woven into the same fabric as space, forming what Einstein called spacetime. And yet, space lets you move freely in any direction. You can go left, right, up, down. Time, however, is a one-way street. You can't moonwalk into yesterday. Why? That's the million-light-year question. Nothing in the basic laws of physics actually forbids time from running backward. The equations work perfectly well in either direction. A movie of 2 billiard balls colliding looks physically valid whether played forward or backward. So why does reality always flow one way? Why do eggs splatter but never unsplatter? The answer seems to lie not in the laws themselves, but in entropy, the universe's ever-increasing appetite for disorder. Imagine the universe at its earliest moment, right after the Big Bang. Incredibly hot, incredibly dense, and incredibly organized, like a cosmic hotel room before the guests arrive. Over billions of years, that tidy beginning has gotten messier. Stars explode, matter clumps, galaxies scatter like marbles on a polished floor. Entropy is increasing, and that increase gives time its direction. The more things fall apart, the more forward time moves. It's as if the arrow of time is tattooed on the universe's untidy desk, pointing from clean to cluttered. This view makes time feel less like a fundamental feature of reality and more like an illusion created by change. Without change, time would have nothing to measure. If every atom stayed perfectly still, you could set your watch to infinity and it wouldn't matter. That's what makes entropy so sneaky. It turns chaos into a clock. Whenever the universe rearranges itself, we get a sense of motion, and that motion gives birth to time. Here's a fun thought experiment. Take a deck of cards, perfectly ordered from ace to king. That's low entropy, neat and predictable. Now shuffle it. The more you shuffle, the messier it gets, and the less likely it is to return to its original order. Each shuffle is like a tick of cosmic time, moving you forward into greater disorder. Eventually, you can't get much messier, and the deck reaches what physicists call maximum entropy, the universal equivalent of giving up and saying, good enough. So maybe time isn't a river flowing toward the future. Maybe it's just the trail of breadcrumbs left by entropy as it eats its way through the universe. That might sound grim, but it's actually the reason anything interesting happens at all. Stars shine because entropy increases. Life exists because energy moves from hot to cold, from order to disorder. We live in a constant exchange between what's structured and what's breaking down, and that imbalance keeps everything dynamic. In a completely entropic universe, one that's perfectly balanced and still, time would stop. There would be nothing left to change, no decay, no growth, no story to tell. That brings us to the strange truth about how humans perceive time. We feel it because we notice change. Your reflection looks older, your coffee cools, your phone battery dies faster than your motivation. But in a universe with no difference between now and later, those sensations wouldn't exist. Time, then, is less like a flowing current and more like a side effect of motion and memory. It's our way of labeling the difference between two states of existence, one slightly more chaotic than the last. Physicists have even suggested that if entropy could somehow decrease, a local reversal of disorder, then time might appear to run backward in that region. Imagine walking into a messy room and watching it clean itself, shirts folding, dust reversing mid-air, pizza box resealing. That's not just impressive housekeeping. It's physics flipping the script. Of course, in practice, the odds of that happening are so astronomically low that you'd have better luck watching a snowflake survive inside the sun. And so, time's resume turns out to be less about cosmic authority and more about cosmic laziness. It's the byproduct of the universe's ongoing tendency to make a bigger mess. But that messy tendency is what allows stars to burn, atoms to bond, and us to exist long enough to wonder what it all means. Time doesn't march forward because it wants to. It stumbles forward because the universe keeps tripping over its own entropy. So maybe time isn't the boss we thought it was. Maybe it's the intern, recording all the chaos as it happens, filing reports in one direction because that's the only way the paperwork makes sense. And as the universe keeps spiraling toward disorder, time will keep dutifully stamping progress on every broken star, every melted ice cube, and every missed deadline, whispering the same truth to everything it touches. You were cleaner yesterday. If the universe had an autobiography, the first chapter would probably be called The Big Bang, and it would start with an explosion so huge it makes every fireworks show in history look like a sparkler in a hurricane. But here's the cosmic twist. The Big Bang wasn't really an explosion in space. It was an explosion of space. And according to the most accepted version of the theory, it wasn't just space that began in that moment. It was time itself. This idea alone is strange enough to make your brain do the cosmic equivalent of buffering. If both space and time started with the Big Bang, then asking what happened before it is like asking what's north of the North Pole. The concept doesn't even apply. Time, as we know it, didn't exist. There was no before for anything to happen in. The universe didn't come from something. It simply came to be. And yet, despite how tidy that sounds on paper, it leaves scientists deeply uneasy. Because if there truly was nothing before the Big Bang, not even time, then how did the universe decide to start existing at all? The Big Bang Theory is excellent at describing what happened after the beginning. About 13.8 billion years ago, all the matter and energy we know of was compressed into an unimaginably dense hot state, something physicists call a singularity. Then, in less than a heartbeat, everything began expanding, not into empty space, but expanding space itself. Galaxies formed, atoms assembled, and one day a small species of curious primates looked up at the sky and asked, "What started this whole thing?" But when we trace the clock backward, closer and closer to the start, we hit a wall. The laws of physics stop cooperating. Gravity, quantum mechanics, energy, everything collapses into mathematical nonsense. It's like trying to rewind a movie only to find the first frame missing. So scientists began to wonder if maybe the Big Bang wasn't the beginning, but rather a transition. Imagine a glass of water suddenly freezing into ice, not appearing from nowhere, but shifting from one state to another. Perhaps the universe, too, transformed from something else, something timeless, into what we now call space and time. In that case, the Big Bang wasn't the birth of existence. It was just when existence changed its form and, as one might say, got loud. Quantum physics offers a few strange possibilities here. One idea suggests that before the Big Bang, there was a quantum vacuum, not empty space, but a roiling ocean of energy where particles and antiparticles flickered in and out of being, borrowing existence for microscopic instants. In this timeless quantum stew, the universe could have existed in a kind of potential state, not yet unfolding because time hadn't started ticking. Then, perhaps through a random fluctuation, a tiny bubble of this energy expanded, and that bubble became everything. It didn't happen in time. It created time as it inflated. It's unsettling, isn't it? The thought that our entire reality might have sprouted spontaneously, like a cosmic hiccup. Yet, it fits surprisingly well with what quantum mechanics tells us about how things behave on the smallest scales. Particles pop in and out of existence all the time, borrowing energy from nothingness and returning it almost instantly. Maybe our universe is just a particularly ambitious version of that, a quantum event that decided to stick around. Other scientists take it even further, suggesting that the Big Bang might not have been the first bang at all. In some models, the universe expands and contracts endlessly, like a cosmic accordion. Each collapse triggers another expansion, over and over, through countless cycles. If that's true, then the Big Bang was just the most recent encore in an infinite concert. The universe could be older than time as we define it, an ancient rhythm that occasionally hits the reset button. There's even a theory that space and time themselves are emergent properties, meaning they didn't exist independently before the Big Bang, but arose from deeper, more fundamental relationships, like music emerging from vibrations on a string. In that case, asking what came before might be meaningless, not because nothing existed, but because the concept of before simply didn't apply until the melody of time began to play. Still, not everyone is comfortable with that. Humans crave beginnings. We like cause and effect. We like stories that start with once upon a time. The idea that the universe might not have a beginning at all feels emotionally wrong, even if it makes scientific sense. But maybe that's just our limited experience talking. We think of time as a straight line, past, present, future. Yet, in the equations that govern the cosmos, time can bend, loop, and even stop behaving altogether. The Big Bang might not be the first page of the book, but a crease in the paper, where something folded and a new story began. What makes this mystery so deliciously frustrating is that every time we think we're close to understanding the beginning moves. The more we peer backward, the less time seems like a solid foundation and more like a side effect of something deeper and stranger. The Big Bang, then, isn't the universe's birth certificate. It's just the first readable chapter of a much older saga, one whose prologue is written in equations we haven't yet learned to translate. So maybe the Big Bang wasn't the start of everything. It was the universe's first loud announcement, the moment potential became performance. Before it, there might have been silence, an eternal stillness waiting to vibrate. And when it finally did, time began its relentless march, space began to stretch, and somewhere in that endless unfolding, atoms formed, stars ignited, and beings like us appeared, asking, in a language the cosmos can barely hear, what came before? If the Big Bang's timing problem teaches us anything, it's that before and after might just be human habits. The universe doesn't need them. Maybe it simply is. And we're the ones trying to fit infinity into the comfort of a clock. Before time began, if before even makes sense, the universe may have been nothing more than a restless sea of possibility. Not a void, not a vacuum, and definitely not nothing in the everyday sense, but something much stranger, a quantum soup. Picture an invisible ocean that never sits still. It has no temperature, no color, no direction, just endless fluctuations of energy popping in and out of existence. Physicists call this the quantum vacuum, but don't let the word vacuum fool you. This isn't the peaceful emptiness of space. It's a cosmic blender running on pure uncertainty. In this bizarre realm, particles appear and vanish faster than a magician's rabbit. One moment there's something, the next there's nothing, and then, surprise, it's something again. These fleeting bursts of existence are called quantum fluctuations, and they're not theoretical. Scientists have measured their effects. They make tiny adjustments to the energy of atoms, nudge the orbits of electrons, and even contribute to what's known as vacuum energy. In other words, what we think of as empty space is actually buzzing with invisible activity. It's like a dance floor where reality keeps changing partners before the music even starts. Now here's the weird part. In the quantum world, things don't need a reason to happen. They just do. The uncertainty principle, the rule that says we can never know both a particle's position and momentum precisely, means that nature is fundamentally jittery. Even when you remove all particles, strip away all energy, and cool everything to absolute zero, there's still motion. The vacuum refuses to sit still. It's as if the universe has a built-in case of existential fidgeting. So what happens when that fidgeting goes too far? One theory says that our universe was born when a fluctuation in this quantum vacuum didn't disappear. It was a hiccup in nothingness that refused to settle back down. Most fluctuations cancel themselves out in the blink of an eye. But maybe, once in an unfathomable while, one grows large enough to become stable. That's when the magic, or madness, happens. The fluctuation expands, the energy condenses into particles, space stretches, and suddenly you've got stars, galaxies, planets, and a species of curious primates wondering how it all began. If that sounds improbable, well, it is. But in a quantum vacuum, improbable doesn't mean impossible. Think of the vacuum like an infinite casino where every outcome, no matter how unlikely, will eventually happen given enough rolls of the dice. Most rolls produce fleeting, unstable mini-universes that collapse before they even begin. But one roll, ours, hit the jackpot. The dice came up existence, and the winnings are everything you can see, touch, and think about. In this picture, the universe didn't emerge from something. It emerged as something. It was a self-contained burst of possibility, expanding from a quantum fluctuation into space-time itself. The laws of physics didn't guide this process. They emerged from it. Like bubbles forming in boiling water, universes could be constantly budding off from the quantum foam, each with its own physical rules. Some might blink out instantly, others might stretch forever. We just happen to live in one where the recipe worked. What's unsettling and thrilling is that this idea blurs the line between existence and non-existence. If the vacuum can produce something as vast and complex as a universe, can we really call it nothing? Maybe nothing isn't an absence at all, but a condition of potential, a blank canvas that can't help but paint itself. The quantum vacuum, in that sense, is reality's engine idling in neutral, waiting for the next spontaneous gear shift into being. Of course, our everyday intuition rebels against this. In normal life, things don't just appear without cause. You don't walk into your kitchen and find a brand new toaster that's spontaneously assembled from air molecules. But on the quantum scale, causality gets fuzzy. Particles don't follow predictable paths. They exist in clouds of probability. They don't obey strict laws of before and after, because those concepts depend on time. And in the quantum soup, time hasn't yet clocked in for work. Everything happens all at once, or maybe not at all, depending on how you look at it. This leads to one of the strangest implications of all. Maybe the universe didn't need a cause. It could have simply been a random fluctuation that stuck around, stabilized by its own internal rules. Once it began expanding, time and space became measurable, and the laws of physics solidified like cooling lava. What we call the beginning was actually a phase transition, from the formless quantum haze to the structured cosmos we live in now. If that's true, then our entire existence is a statistical accident, a lucky draw from the deck of infinite quantum chaos. Somewhere out there, beyond our reach, other bubbles might be forming right now, other universes inflating with their own peculiar flavors of physics. Some could be governed by completely different constants, or maybe no constants at all. Worlds where gravity repels, light never slows, or time runs in circles. We'll never see them, but their possibility reminds us that our reality might be one version among countless cosmic experiments. It's almost poetic. Before the universe was born, there wasn't peace or silence. There was restless potential. The quantum vacuum wasn't nothingness. It was everything waiting to happen, a timeless ocean murmuring with half-formed realities. Out of that infinite uncertainty, one bubble refused to fade, one fluctuation inflated, and that stubborn blip became the universe. So when we look at the night sky, at all those stars burning billions of years away, we might be seeing the result of a single quantum twitch that refused to quit. The cosmos is, in essence, a ripple of persistence in a sea of chance, a hiccup that became a symphony. And if that's true, then our existence isn't a miracle in spite of nothingness. It's the natural consequence of nothingness, being just a little too restless to stay that way. If the universe could stretch into a yoga pose, it would probably be the no-boundary position, flexible, elegant, and profoundly confusing to anyone trying to follow along. In the early 1980s, two theoretical physicists, Stephen Hawking and James Hartle, proposed a model so daring that it made the Big Bang look like the warm-up act. Their idea? The universe doesn't have a beginning. Not in the usual sense, anyway. According to them, time itself might curve back on itself, forming a smooth, finite shape with no edges, no boundaries, and crucially, no before. To picture this, imagine the surface of the Earth. If you travel north, eventually you'll reach the North Pole. But try to go farther north from there, and the question stops making sense. There's no north of the North Pole. Hawking and Hartle suggested that time might work the same way. If you trace it backward to the earliest moments of the universe, you reach a point, like the North Pole of time, where before simply ceases to have meaning. The universe doesn't need a beginning any more than the Earth needs an edge. It's self-contained, finite, and curved back upon itself, a cosmic globe floating in space-time. This is what they call the no-boundary proposal. It was their answer to the problem that had haunted cosmology for decades. What came before the Big Bang? In their model, the universe didn't burst forth from a singularity, a point of infinite density and nonsense, but instead emerged smoothly, like the way dawn transitions into daylight. The beginning wasn't a sharp edge, but a soft curve, where time gradually emerged from something more spatial. Before time began ticking, there was only space, gently bending until, somehow, it started moving. To make this less abstract, and possibly to stop our brains from melting, think of the universe not as a timeline, but as a landscape. In this landscape, space and time are two directions you can move in. According to the no-boundary model, near the beginning, time starts to behave more like space. There's no sudden line between nothing and something. Instead, time just fades in, like the first frame of a movie slowly coming into focus. It's a cosmic sunrise where the concept of before is replaced by a smooth transition from timelessness to timefulness. The beauty of the Hartle-Hawking model lies in its simplicity. No edge, no start, no singularity. The universe is finite but unbounded, like the surface of a sphere. If you were a two-dimensional being living on a balloon, you could travel forever without finding an edge, and yet the balloon's surface would still be finite. The same could be true of our four-dimensional universe. You can go back in time only so far before the concept itself bends back on you. Time, it turns out, might be circular in a way that doesn't repeat, more like a loop that closes elegantly at its base. Of course, this idea messes with every instinct we have about beginnings. Humans like origin stories. We want to know who lit the first spark, What triggered the first cause? What came before the first second? But Hawking and Hartle were saying there was no trigger. The universe didn't need one. It simply existed because existence was the most natural state available. The laws of physics allowed it, and so it happened. Asking what came before time in this view is like asking what's north of the North Pole, or what flavor an invisible color might be. The question itself dissolves when you reach that curvature. Mathematically, their theory used something called imaginary time, which sounds like something invented by a bored watchmaker, but is actually a legitimate mathematical construct. In imaginary time, the equations describing the universe become smooth and finite. There are no infinities, no singularities, no breakdowns. Everything fits together neatly, like a well-folded cosmic origami. And when imaginary time transitions to real time, the kind we experience, what we perceive as the Big Bang is just the moment when time starts to behave like time instead of space. This doesn't mean the no-boundary universe popped into being without a whisper of explanation. It means the universe is self-contained, governed entirely by its own laws. It doesn't need something outside itself to start it, because the concept of outside doesn't apply. It's like a story that begins in the middle but still makes perfect sense once you've read enough pages. The universe is its own author and its own setting, writing the first line the moment it learned to measure itself. There's something quietly revolutionary about this idea. For centuries, cosmology was haunted by the question of creation, by the search for an ultimate cause, a first mover, a divine clockmaker. But the no-boundary model suggests that maybe the universe didn't need a clockmaker because the clock wound itself. In Hawking's words, asking what caused the universe is meaningless if time itself is part of the universe. There's no moment when the match was struck because the concept of moment hadn't been invented yet. It's humbling to think of existence this way, as something without an edge, without an outside, without a before. The no-boundary universe isn't infinite in the sense of stretching forever. It's infinite because it closes perfectly upon itself. Every direction leads back into the whole. Every question about the beginning loops into an answer about the present. It's cosmic yoga, all right. The universe bending so elegantly that its head touches its toes, and in that graceful curve, time itself disappears. If the Hartle-Hawking model is right, then the universe isn't a miracle that burst from nothing. It's a natural shape, a closed, seamless bubble of space and time that simply is. And maybe that's the real miracle. Not that the universe had a beginning, but that it doesn't need one. Because when you reach the edge of understanding, and the edge isn't there, you realize something profound. Perhaps the universe never started. It's just been stretching, breathing, and curving this entire time, holding the pose perfectly since forever began. If you ever want to question the meaning of existence, just open a physics textbook. You'll notice something oddly unsettling hiding between all the symbols in Greek letters. Time doesn't seem to matter as much as you think it should. Many of the universe's most fundamental equations, the ones that describe how everything works, operate just fine without it. It's as if reality keeps running smoothly even when time steps out for a lunch break. Let's start with the big one, Newton's laws. These are the elegant rules that tell us how objects move and how forces interact. They describe acceleration, momentum, and gravity, and yet, if you flip the direction of time in them, nothing breaks. Drop a ball and watch it fall. Then imagine the video played backward. The equations describing both scenes are equally valid. The same goes for Einstein's theory of relativity, which treats time as just another dimension, like height or width, woven into the fabric of space. Nothing in those equations tells the universe which way time should flow. Forward, backward. It's all the same to the math. This is deeply weird. We experience time as a river, always moving forward, carrying us from the past into the future. But the equations that govern reality treat it like a lake, still, symmetric, and indifferent to direction. In fact, many physicists now suspect that time, as we experience it, isn't a fundamental ingredient of the cosmos at all. It's more like a side effect, a property that emerges when you zoom out far enough to notice things changing. To grasp this, imagine the universe as a photograph rather than a movie. Every moment exists as a static frame, a frozen configuration of matter and energy. The passage of time, then, isn't something the universe is doing. It's something we perceive as our consciousness moves through these frames in sequence. In physics, this idea is sometimes called the block universe. In this model, the past, present, and future all exist simultaneously, like pages in a completed book. We just happen to be reading it one word at a time. But if that's true, why does time feel so real? Why does yesterday feel gone and tomorrow feel like it hasn't happened yet? One answer lies in a curious possibility. That time isn't built into the structure of the universe. It's built into the structure of our understanding of it. When we measure change, compare one state of the universe to another, and notice that things aren't identical, we invent a concept called time to keep track. In that sense, time might be less like a physical substance and more like a mental calendar we impose on the world's ongoing rearrangement. Quantum mechanics takes this idea even further. When you dive into the subatomic world, where particles behave like fuzzy waves of probability, time seems to disappear entirely. The famous Schrödinger equation, which describes how a quantum system evolves, doesn't actually depend on time as a fundamental input. It treats the universe as a timeless web of possibilities, all existing simultaneously. Only when we observe the system does one outcome appear, and with it, our sense of a before and after. Even Einstein's general relativity hints at a similar truth. According to relativity, time can speed up, slow down, or even stop, depending on gravity and motion. Stand near a black hole, and time for you crawls compared to someone far away. From the universe's point of view, there's no universal clock ticking behind the scenes, just a tangled network of events linked by cause and effect. Time isn't absolute. It's local, personal, and negotiable. The cosmos doesn't own a wristwatch. This leads to a daring thought. Maybe time is not part of the universe's foundation, but a story told by the universe's parts. When matter and energy interact, when particles dance and decay, we perceive a flow, but the equations themselves describe relationships, not moments. It's like reading sheet music. There's no sound in the paper itself, only relationships between notes. The music happens when it's played. Similarly, time happens when the universe plays its interactions. Some physicists even suspect that time might emerge from something deeper, perhaps from the entanglement of quantum states. When particles become correlated, sharing information across distance, those correlations could give rise to the illusion of time's flow. In other words, time might be what it feels like to exist inside a system, constantly rearranging its own information. It's not a thing, it's a byproduct of things happening. This idea unsettles even scientists because it suggests the universe doesn't evolve. It simply is. Every configuration of atoms, every event, every moment exists simultaneously in a grand static structure. We experience that structure sequentially because our brains can only process one state at a time. Our consciousness might be the ultimate time machine, turning the frozen geometry of reality into what feels like motion. If you could somehow step outside the universe, hover above the block of space and time like a reader looking down at a book, you wouldn't see a flowing story. You'd see the entire plot laid out all at once, the birth of stars, the rise of life, the death of civilizations, all coexisting in a single, timeless structure. Time wouldn't be something moving, it would be something already there. The ticking of the clock, the fading of memory, the aging of skin. These are the ways our biology interprets that static structure as a journey. And yet the strangest part is how well this timeless view fits the data. The laws of physics don't mind a universe without time. They describe a reality that's self-consistent and complete without needing a ticking clock. Time, it seems, is the universe's most successful illusion. A trick so convincing that even the equations can't fully reveal the sleight of hand. So maybe time isn't a cosmic law, it's cosmic improv. It emerges wherever change happens, wherever relationships shift, wherever consciousness draws a line between then and now. The universe doesn't need it, but we do. Time may not be a fundamental ingredient of reality, but it's the flavor that makes reality worth tasting. Picture the universe without a clock. No ticking seconds, no flowing minutes, no cosmic metronome keeping time. Just pure existence, unchanging, unending, unapologetically still. In such a universe, there's no before or after, no story arc, no progress. There is only is. That's hard for us to wrap our heads around because our entire sense of reality depends on time moving forward. But what if that motion is an illusion? What if the universe isn't a movie playing frame by frame, but a painting, vast, intricate, and already complete? A timeless universe sounds like science fiction, but it's a serious concept in physics and philosophy. Imagine existence as a four-dimensional sculpture. Every moment you've ever lived, your first breath, your next heartbeat, and the far-off moment when your atoms scatter into the cosmos, all exist simultaneously within this grand structure. You aren't traveling through time. You're tracing a path across the shape of your own existence. From your perspective inside the sculpture, it feels like movement, like change, like life unfolding. But from the outside, if such an outside even exists, it's all there at once. In this view, reality doesn't happen. It is. The universe isn't telling a story. It's already finished the novel. We're just reading one page at a time, convinced that the plot is still being written. The past isn't gone. It's a region of the structure we've already passed through. The future isn't waiting. It's a region we haven't reached yet. Everything that has ever been or ever will be coexists, woven together in a frozen web of causality. This idea, often called the block universe, strips away the illusion of time as a flowing river. In a timeless cosmos, change doesn't occur because there's nothing external to measure change against. What we call change is just our perception jumping from one point in the structure to another. It's like flipping through the pages of a flip book. You feel motion because your brain strings together still images, but the book doesn't actually move. Every frame already exists on paper. Now you might be thinking, if everything is frozen, how can we experience anything? How can we think, feel, act, or even breathe in a timeless world? The trick is that consciousness itself might be the illusion that creates time. Our minds construct continuity the way a projector creates a film, by shining awareness across a series of static frames. The frames don't change, but the experience does. The sensation of now is just your brain syncing with one particular frame before moving on to the next. In a universe without a clock, birth and death don't really happen. They're coordinates, not events. You exist in your entirety, past, present, and future, all at once. The version of you who's reading this sentence, the one who read the last chapter, and the one who will one day forget it, they all coexist as part of the same eternal pattern. From your inner viewpoint, life feels like a journey. But from the perspective of the universe, you're already everywhere you're ever going to be. It's unsettling, but also oddly comforting. In a timeless universe, nothing is truly lost. The moments we call past don't fade into non-existence. They simply exist elsewhere in the block. The laughter of extinct species, the collapse of ancient stars, your childhood self, all preserved in the architecture of being. Death, then, isn't an ending. It's just the edge of your particular region in the cosmic sculpture. You don't stop existing. You simply stop experiencing the illusion of motion. The implications are mind-bending. Without time, cause and effect lose their hierarchy. Instead of one event triggering another, all events coexist in a web of interdependence. The Big Bang, the formation of galaxies, the rise of life, they don't unfold in sequence, but form a single interconnected pattern. Think of a spider web. Each strand supports and defines the others. Remove one, and the structure changes everywhere. Time is what that web looks like when experienced from the inside. Eternity is what it looks like from above. Even physics hints at this static reality. The equations that describe the universe don't require a ticking clock to function. They describe relationships between things, not moments. From that perspective, time isn't an ingredient. It's the flavor our minds add when we sample those relationships. Just as color is how our eyes interpret different wavelengths of light, time might be how our consciousness interprets the structure of change. Without observers, there might be no sense of then and now, just the whole tapestry at once. But let's be honest, living in a timeless universe sounds boring. We like progress, suspense, beginnings and endings. A frozen cosmos feels like a story that never moves forward. Yet that's only because we're used to being characters inside the story. From within, it feels alive and dynamic. From the outside, it's perfection frozen in amber. It's both motion and stillness, process and completeness, depending on where you're standing. And maybe that's the point. If time is an illusion, it's the most beautiful one ever crafted. It gives meaning to the static universe by allowing us to experience it sequentially. Without it, existence would be silent and motionless, a cosmic museum of eternal moments. But with time, or at least with the illusion of time, we get narrative, we get growth, decay, love, curiosity, and wonder. We get to be travelers instead of statues. So imagine the universe without a clock. No ticking seconds, no deadlines, no waiting. Everything that will ever happen is already written into the fabric of existence, shining quietly in its place. We, the observers, are the ones wandering through it, translating geometry into story, eternity into experience. In the end, maybe the universe isn't missing a clock. It simply doesn't need one. Because when everything is all at once, there's no need to keep time. There's only the eternal now, stretching endlessly, perfectly still, and infinitely complete. If the universe doesn't need time, then why do we? Why do humans cling to it as though it were oxygen? The answer might be painfully simple. Because our brains are glorified storytellers, and stories need order. Time for us is less a cosmic truth and more a psychological coping mechanism, a mental filing system that keeps reality from collapsing into chaos. Without it, our thoughts would overlap like 50 radio stations screaming simultaneously, each one demanding to be the present. From the moment we wake up, we live under time's rule. We measure our days in slices of sunlight, our lives in birthdays, our histories in centuries. Time structures our memories, our plans, even our emotions. You can feel it in the nostalgia of yesterday and the anxiety of tomorrow. It's not just a clock on the wall. It's the framework inside your skull. Every heartbeat, every thought, every sensation passes through an invisible filter labeled before and after. It's how the brain stays sane. Psychologists have long known that the human mind doesn't experience time as an objective flow. It constructs it. Your sense of time stretching or shrinking isn't about the universe changing pace. It's about how your brain processes information. When you're bored, your brain has little to do, so it checks its internal watch constantly. Time drags. But when you're busy or amazed or terrified, your mind is flooded with data, too distracted to count the seconds, and time seems to vanish. The clock hasn't changed. You have. In a way, time is our brain's greatest illusion, but it's also its most useful one. Without a sense of sequence, life would be incomprehensible. You couldn't tell whether you had eaten breakfast or were about to. You couldn't plan, learn, or remember. Memory depends on the brain's ability to link events in order. It's like building a bridge one plank at a time. Each memory slots neatly after another, giving shape to the story of you. Without that sequence, consciousness would dissolve into static. Our perception of time even shapes our identity. You aren't just a person, you're a timeline. Your past defines who you are. Your imagined future gives you purpose. We construct our sense of self like a movie reel, frame by frame, so that the person in frame 1, the child, and the person in frame 5,000, the adult, feel like the same protagonist. The continuity is artificial, but it's comforting. Without it, you would just be a flickering collection of disconnected moments. Culturally, our obsession with time runs deep. Entire civilizations have been built around measuring it. The ancient Egyptians tracked it with the sun's shadow. Medieval monks regulated it with bells. Modern humans strap it to their wrists and call it punctuality. We even shaped morality around time. Wasting it feels sinful, losing it feels tragic, and racing against it feels noble. Time has become not just a concept, but a moral compass, a measure of productivity, value, and even worth. But for all our clocks and calendars, our perception of time is surprisingly elastic. Trauma can make a single moment feel eternal, while joy can make hours disappear in a blink. The brain's timekeeping mechanisms, networks in the prefrontal cortex, basal ganglia, and cerebellum, don't measure seconds like a stopwatch. They estimate them based on activity and emotion. Fear floods the brain with adrenaline, sharpening attention and slowing time to a crawl. Love, laughter, or awe flood it with dopamine, making time slip away unnoticed. It's also worth noting that different cultures experience time differently. Western societies tend to see it as linear, a relentless arrow pointing toward progress and decay. But many indigenous and Eastern traditions view time as cyclical, a repeating pattern rather than a march. To them, the idea of a single, irreversible timeline is strange. Seasons return, ancestors live through descendants, and events echo through cycles. In a way, they've been closer to the timeless truth all along. Maybe time isn't a ruler we move along, but a rhythm we dance to. Still, our brains resist the idea of timelessness. The human mind craves order because chaos feels like death. Time gives us cause and effect, safety in sequence, meaning in movement. Without it, reality would feel like an incomprehensible flood of sensation, sight, sound, thought, and feeling all happening at once. We would drown in the simultaneity of existence. So we carve lines through the chaos and call them minutes. We invent now so that everything else can become then. This habit of structuring time might even be the secret engine of consciousness itself. The brain doesn't just observe the world, it predicts it. It constantly compares what's happening with what just happened and what might happen next. That predictive loop creates the illusion of flow, the continuity we call awareness. In a timeless universe, Our minds generate time so we can make sense of motion, memory, and meaning. We turn stillness into sequence because that's the only way we know how to think. It's ironic, really. Time might not exist out there in the cosmos, but it rules every second of our inner lives. It tells us when to wake, when to work, when to love, and when to say goodbye. It's the ghost in the human machine, the structure behind our stories, the scaffold of our sanity. Without it, thought would be chaos, identity would dissolve, and experience would collapse into a single, eternal, indecipherable moment. So maybe time isn't something the universe invented. Maybe it's something we invented to survive the universe. A coping mechanism, a narrative trick, a habit we can't quit. Because if we stopped measuring time, stopped dividing life into before and after, we might finally see what existence really looks like, and it might be too much to bear. Without time, there's no next breath, no future promise, no comforting sense that the story continues. There's just the overwhelming truth of now. And maybe that's why humans can't let go of time. We don't need it because the universe does. We need it because we do. It's not the clock that keeps us alive. It's the rhythm it gives to the silence. Every day you witness the arrow of time in action. You see it when you spill your coffee, when your ice cream melts, when your hairline retreats like a timid tide. Things fall apart, never the other way around. The arrow points forward relentlessly from order to disorder. You never see a broken egg leap back into its shell or a crumpled paper unwrinkle itself. Time, it seems, has a favorite direction, and it's always downhill. But what if that wasn't always the case? What if the arrow of time didn't exist at the beginning of everything, but appeared only after the universe got messy enough to need it? The concept of the arrow of time was first described by physicist Arthur Eddington in the 1920s, and it's one of the strangest paradoxes in physics. The fundamental laws that govern particles, the equations of motion, electromagnetism, even quantum mechanics, are perfectly symmetrical. They don't care which way time flows. A simulation of particles bouncing around would look just as valid in reverse. Yet the world we live in is clearly not symmetrical. Glass shatters, but doesn't reassemble. Stars burn out, but don't reignite. You age in one direction, not both. Something, somewhere, gives time its sense of direction. And that something is entropy. Entropy, the universe's gradual slide from order into chaos, is what defines the arrow's tilt. It's the cosmic principle that says systems naturally move from tidy to tangled. A deck of cards starts neat and ends shuffled. A room starts clean and ends looking like a tornado auditioned for a dance competition. Entropy increases because there are more ways for things to be disordered than ordered. There's only one way for all your socks to match, but a million ways for them to disappear. Now here's where it gets truly fascinating. At the birth of the universe, entropy was shockingly low. That's weird, because if chaos is natural, You'd expect the cosmos to have started in a messy state. Instead, it began almost unnaturally smooth, like a freshly ironed bedsheet stretched across existence. Matter and energy were evenly spread out, and the universe was almost perfectly uniform. That pristine beginning is what allowed entropy to increase over time, because there was still plenty of room for things to get messier. Without that low entropy starting point, there wouldn't even be an arrow of time to speak of. So why was the early universe so orderly? That's one of physics' biggest unsolved mysteries. Some theories suggest that inflation, the rapid expansion after the Big Bang, smoothed everything out, ironing the wrinkles of chaos before the arrow could form. Others propose that what we call the beginning might not have been a beginning at all, but a transition from a previous phase where time didn't exist. In that case, the arrow of time might have been born the moment order began losing the fight against disorder, when the universe took its first step away from perfection and into possibility. If time's arrow is tied to entropy, then before the arrow existed, there could have been no before and after in any meaningful sense. The early universe may have been timeless, a state of perfect equilibrium where nothing changed because nothing needed to. Only when slight imperfections crept in, tiny fluctuations in energy and matter, did the universe begin to differentiate, and with differentiation came direction. Time began flowing, not because a clock started ticking, but because symmetry broke. The universe started favoring one direction over another, forward into disorder. It's oddly poetic that time, the thing we experience as movement and progress, might have been born out of imperfection. Without that imbalance, we wouldn't have galaxies, stars, or life. Entropy may be the universe's slow surrender to chaos, but it's also the reason anything happens at all. Without it, the cosmos would be a silent, static perfection. Beautiful, maybe, but lifeless. The arrow of time is the price the universe pays for creativity. But if time's direction depends on entropy, could it ever reverse? Theoretically, yes, but only if entropy stopped increasing and began to decrease. Imagine a universe contracting instead of expanding, cooling instead of heating, gathering its pieces back into order. In such a world, time might appear to flow backward. You'd see the ashes leap into flame, the dead rise from dust, and spilled milk return obediently to its glass. It sounds absurd, but the equations allow it. The problem is, entropy doesn't play nice with symmetry. It's a one-way ticket to messiness. Once the arrow points forward, it's nearly impossible to turn it around. Still, there's a haunting thought buried in there. Maybe time's arrow isn't permanent. Some cosmologists believe that in the far, far future, after every star has burned out and black holes have evaporated, the universe might reach a state of maximum entropy, where nothing more can happen. In that frozen eternity, the arrow of time would disappear. There would be no motion, no decay, no change, just a vast, unending stillness. And in that stillness, perhaps time itself would lose meaning again, just as it did before it began. If that's true, then the arrow of time is not a fundamental law, but a temporary phenomenon, a ripple in the cosmic fabric. It's the universe remembering how to move, how to evolve, how to tell a story. When order first fractured, the arrow appeared, giving direction to chaos. When the last bit of order finally fades, the arrow may vanish and the universe will fall back into timeless quiet. So the next time you drop a cup and watch it shatter, remember, you're witnessing the universe's arrow at work, the grand story of entropy in miniature. Every broken thing, every faded memory, every passing second is a whisper from that first moment when the cosmos decided to move forward. The arrow of time may have lost its way before it began, but once it found direction, it never looked back. If you've ever restarted your computer after it froze, you already understand one of the strangest ideas in cosmology, the cyclic universe. Imagine that the entire cosmos has a built-in reset button. Every time it crashes under the weight of its own gravity or expands too far into emptiness, it reboots. New space, new time, new physics, same underlying system. It's the ultimate cosmic operating system, endlessly reinstalling itself, each version running a little differently, maybe with slightly fewer bugs. This isn't just poetic metaphor. It's a serious scientific proposition known as the cyclic model or conformal cyclic cosmology, depending on which version you prefer. In these models, the universe doesn't have a beginning or an end. It has a rhythm. It expands, cools, collapses, and then starts all over again, like a cosmic heartbeat that takes trillions of years per beat. The Big Bang, in this picture, wasn't a one-time event, but just the latest in an infinite series of cosmic reboots. We might be living in Universe 12.0 without even knowing it. One of the earliest hints of this idea came from an ancient question. If the Big Bang was the beginning, what came before it? The standard model of cosmology doesn't have a satisfying answer. It just says, time started there. But the cyclic model shrugs and says, before this universe, there was another one. When one universe reaches the end of its life, its stars burned out, its matter dispersed, its black holes evaporated, it becomes so stretched and smooth that it's indistinguishable from a new beginning. Entropy, the great destroyer of order, resets because there's nothing left to disorder. The slate wipes itself clean, and the next universe bursts forth. It's a strangely elegant way to dodge the problem of cosmic origins. You don't need a singular beginning, because beginnings and endings are the same thing viewed from different sides of the loop. Think of it like seasons. Winter looks like an end, but it's really the setup for spring. In this endless cycle, universes rise and fall like waves, each one giving birth to the next. Our Big Bang could have been the death throes of a previous cosmos collapsing in on itself, a final exhalation that became our first breath. The notion of loops doesn't stop at entire universes, though. Time itself might loop on smaller scales. Imagine moments repeating endlessly, not because you're trapped in some mystical déjà vu, but because space-time is curved in such a way that paths through it circle back to where they started. These are called closed time-like curves, and they pop up as possible solutions in Einstein's equations. In theory, if you traveled far enough along one of these loops, you'd eventually end up at your own past. You could meet yourself, shake your own hand, and create the kind of paradox that makes physicists sigh deeply into their coffee. Science fiction loves this idea, of course, the endless time loop where you relive the same day until you get it right. But in physics, it's not entirely fiction. Certain models of rotating universes, such as Kurt Gödel's solution to Einstein's equations, naturally produce closed loops in time. In such a universe, you wouldn't need a time machine. You are the time machine, perpetually orbiting through your own history. The only catch is that physics, as we know it, tends to frown on paradoxes. Loops raise uncomfortable questions. If you can go back and change something, how do you avoid unmaking yourself in the process? Some scientists think the universe solves this problem elegantly. It doesn't let paradoxes happen. The Novikov self-consistency principle suggests that even if you could travel backward in time, you could only do things that are already part of history. You might visit the past, but you can't rewrite it. You're just fulfilling it. The loop always closes perfectly. The universe, in that sense, edits its own script before we can mess it up. But loops might not just exist in time. They might also exist across timelines. Quantum mechanics introduces the tantalizing idea that every possible outcome of every event might actually happen somewhere. You decide to go left, another version of you goes right, and both realities coexist in parallel. These branching universes form what's known as the many worlds interpretation. It suggests that reality is less like a single thread and more like an infinitely branching tree. Each decision, each quantum fluctuation spinning off a new timeline. Now combine that idea with the cyclic model and things get wild. Instead of one universe looping endlessly, maybe every loop spawns infinite variations, an endless forest of universes, each one shaped by tiny differences in how the last cycle ended. Perhaps every reboot tweaks the cosmic constants just slightly, like an algorithm fine-tuning itself across eternity. Gravity a bit stronger here, light a bit slower there. Some universes collapse quickly, others expand forever. We happen to live in one where the settings were just right for stars, planets, and nervous creatures who can ask questions like this. If this grand looping system exists, it could explain why the universe seems so finely tuned for life, without invoking coincidence or design. Maybe the cosmic operating system has been running endless beta tests, and we're just one of the stable builds that managed not to crash immediately. Somewhere out there, or rather out when, there might be versions of reality that failed spectacularly. Universes that collapsed before atoms formed, or that expanded so quickly nothing ever condensed. Ours is the one that worked well enough to get curious about itself. Of course, we can't observe the previous cycles or alternate timelines, at least not directly. But some cosmologists think faint traces might survive. Ripples in the cosmic microwave background, tiny patterns of energy that don't quite fit our models, could be the fingerprints of a previous universe whispering through the walls of our own. If we ever confirm that, it would mean our cosmos is just one note in a symphony without beginning or end, a song that keeps remixing itself through eternity. So, whether the universe loops, cycles, or branches infinitely, one thing seems certain. Reality may be far less linear than it feels. The arrow of time might not point straight forward, but curve gracefully into a spiral, returning again and again to its own origins. The universe, in that case, isn't marching toward oblivion. It's dancing in circles, rebooting itself every few trillion years, polishing its imperfections with each spin. And who knows, maybe one day, when this version finally crashes, the next universe will wake up, blink its newborn stars open, and whisper the same ancient question we're asking now. Has this all happened before? Time, as we know it, never seems to sit still. Everything ticks, beats, decays, or changes. Clocks turn, atoms vibrate, stars burn, and even you are a slow-motion metamorphosis of cells and memories. But in 2012, something extraordinary shook that assumption. A discovery so strange it sounded like a punchline to a cosmic joke. Physicists found a new kind of matter that seems to move in time without actually expending energy. They called it a time crystal, and it's as if someone built a clock that runs forever but never needs to be wound. To understand how absurd that sounds, let's first rewind, no pun intended, to what a normal crystal is. Take salt or quartz, for example. Their atoms are arranged in repeating patterns through space, tiny symmetrical lattices that give them shape and structure. A time crystal does something similar, but instead of repeating in space, it repeats in time. It changes rhythmically without burning fuel, radiating heat, or breaking down. Imagine a pendulum swinging back and forth forever. No friction, no loss of momentum, no energy input, just perpetual motion. That's not supposed to happen. In the ordinary world, perpetual motion is the stuff of fantasy and scam patents. The laws of thermodynamics are very clear. You don't get something for nothing. Everything that moves eventually slows down. Every clock runs out of battery. Every living thing runs out of time. So when Nobel Prize-winning physicist Frank Wilczek first proposed the concept of time crystals, many thought he was kidding. A system that oscillates eternally without using energy? It sounded like a violation of the universe's most sacred rule book. But the math checked out, and within a few years, experiments proved it could be done, sort of. Physicists created time crystals using trapped ions and superconducting circuits. In these setups, particles interacted in just the right way so that the system repeated its state over time, like a dance that never tires, a metronome that never misses a beat. The catch is that these systems aren't truly defying the laws of physics. They're bending them cleverly. Time crystals aren't perpetual motion machines. They're quantum objects existing in a delicate state where energy input and loss cancel perfectly. It's not cheating exactly. It's just an elegant loophole in nature's accounting. What makes this so fascinating is what it implies about time itself. In traditional physics, systems evolve because energy moves through them. Time is the stage on which that evolution unfolds. But time crystals flip the script. They exhibit motion without energy flow, rhythm without cause. It's as if time itself becomes part of the system structure, crystallized into a repeating pattern. They don't just exist in time, they are made of time's rhythm. That's where things get delightfully weird. If matter can exist in repeating patterns through time, does that mean time isn't a continuous flow after all? Maybe it's granular, quantized, like everything else in the quantum world. Space, after all, comes in discrete chunks at the Planck scale. Maybe time does too. Time crystals might be tiny glimpses of this deeper reality, frozen music notes in the score of existence. Instead of time being an unstoppable current, perhaps it's a sequence of beats, and some systems have figured out how to hum along indefinitely. Even more intriguing is how time crystals challenge the notion of equilibrium. Normally, a stable system rests. It stops changing when it's reached balance. But a time crystal's resting state is motion. It doesn't settle down. It settles into rhythm. This is a radical departure from everything physics used to believe. It's as if nature itself is tapping its foot to an eternal beat, revealing that motion may be more fundamental than stillness. On a philosophical level, time crystals force us to question whether time's flow is an intrinsic property of the universe or just an emergent illusion. If something can move without change, oscillate without decay, and exist in a perpetual now, maybe time doesn't flow at all. It cycles. Maybe what we perceive as the forward march of time is actually just our consciousness catching the rhythm of a much deeper oscillation, one that never began and will never end. It's tempting to think of these crystals as the universe's smallest musicians. Each one keeps time not for our clocks, but for reality itself. And while they don't break the laws of physics, they expose how flexible those laws really are. They remind us that what we call impossible is often just what we haven't seen nature do yet. But beyond the poetry, time crystals have practical implications. They might one day revolutionize quantum computing by acting as ultra-stable timekeepers that resist noise and decoherence. In a world where quantum bits, or qubits, constantly struggle to maintain coherence, a system that naturally oscillates in sync could serve as a kind of heartbeat for future computers, machines that run not just through time, but with time. Still, the deeper wonder of time crystals isn't technological, it's existential. They blur the boundary between motion and rest, between cause and continuity. They hint that time, the one thing we all feel slipping through our fingers, might not be slipping at all. It could be standing still in patterns too subtle for our senses to detect, repeating endlessly like the rhythm of a cosmic drum we only faintly hear. So perhaps time doesn't flow the way we imagine. Perhaps it hums. Perhaps the universe isn't a river rushing forward, but a vast symphony of loops, cycles, and beats, some slow as galaxies turning, others fast as quantum ripples. And among them, time crystals sit as quiet reminders that the line between movement and stillness, between was and is, may not be a line at all. It may be a rhythm that has never stopped playing since the universe first learned how to keep time without needing a clock. If the universe feels big, that's only because we're thinking too small. What if our cosmos, our galaxies, our physics, our entire space-time, was just one room in a sprawling cosmic mansion. That's the idea behind the multiverse, a vast collection of universes, each with its own laws, constants, and maybe even dimensions. But here's where the idea takes a turn so strange, it makes your neurons hesitate. What if those universes don't share the same clock? Or worse, what if some of them don't have clocks at all? We're used to thinking of time as universal, like an omnipresent background soundtrack that plays the same beat everywhere. But if the multiverse exists, there's no reason each universe would have to follow the same rhythm, or any rhythm at all. They could be like movies playing on infinite screens, each starting whenever it wants, some running fast, others barely moving, and a few frozen on their opening frames forever. From their own perspectives, each film feels complete, coherent, self-contained. But seen from beyond, it's chaos, an endless theater of unsynchronized stories. Let's start with the most grounded version of this idea, the inflationary multiverse. According to inflation theory, our universe began as a tiny pocket of space within a vast inflation field that was expanding faster than light. Within this expanding field, new pockets, new universes, could form endlessly, each bubbling into existence with its own version of physics. It's like boiling water, where each bubble is a separate universe, with its own internal conditions. In some bubbles, gravity might be stronger. In others, light might bend differently. In ours, the constants just happen to allow stars, atoms, and late-night existential conversations. Now think about what that means for time. Inside each bubble, time behaves according to local rules. Our bubble has a timeline that stretches from the Big Bang to the distant future. But outside our bubble, time as we know it might not even exist. The inflation field could be timeless, a sea of potential where universes form not in sequence, but in a timeless foam of possibility. From that perspective, all bubbles exist simultaneously, or rather, beyond simultaneity. The question, which universe came first, wouldn't make sense. They're not lined up in order. They're suspended together in a timeless field of creation. This is where things get delightfully brain-twisting. If time isn't universal, then there's no shared now across the multiverse. Our now might correspond to another universe's distant past, or to another's far future, or to no moment at all. It's like trying to synchronize watches between two dreams. Each one unfolds according to its own internal logic, blissfully unaware of the other. Even if two universes could somehow interact, they might not be able to agree on when that interaction happens, because when doesn't mean the same thing in both. Some physicists, like Max Tegmark, have gone further, proposing that time might be a local phenomenon, an emergent property of each universe's internal structure. In other words, each cosmos invents its own clock. Ours measures the expansion of space and the decay of particles. Another universe might measure time differently, or not at all. Imagine a world where every atom is frozen in perfect equilibrium, no motion, no change. From our perspective, that universe is timeless, a still photograph. But from within, its inhabitants, if they exist, might experience something entirely alien, perhaps a kind of existence where sequence doesn't apply, and awareness is constant, unblinking. If that sounds abstract, think of it like this. In our universe, time is the distance between events. But what if another universe is built differently, where events don't occur linearly? Maybe everything there happens all at once, like chords instead of notes. We hear reality as a melody. They hear it as harmony. In that world, asking what happened before would be like asking what color comes before blue. It's simply the wrong kind of question. There's also the eerie possibility that universes could exist where time runs backward relative to ours. If entropy defines the arrow of time, then a bubble universe with reversed entropy could experience its own history in reverse. What we see as its ending, it experiences as its beginning. To us, its timeline would look like a movie rewinding, but from its perspective, everything feels perfectly normal. Somewhere right now, or right then, there could be beings watching our universe unfold backward, wondering why we're the ones running in reverse. Philosophically, a multiverse without a universal time poses uncomfortable questions about causality. If there's no shared clock, can anything in one universe truly affect another? Probably not. Each bubble would be sealed off, causally disconnected, living out its own reality. It's an unsettlingly lonely idea. Infinite universes existing side by side, none aware of the others, each convinced it's the only one that exists. And yet, the absence of shared time might be what makes their coexistence possible. Without a single clock binding them, they can all exist simultaneously. Though simultaneously is a word that barely survives the journey across that thought. The irony, of course, is that we can barely imagine timelessness because our imagination itself runs on time. Every thought you have has a beginning and an end. Every sentence you read flows from left to right. We're temporal creatures trying to picture what it means to be untethered from the very thing that gives us sequence and meaning. It's like trying to smell a color. The moment we think about timelessness, we've already placed it after the thought before it. Still, it's strangely beautiful to think that reality might be more like a cosmic orchestra than a single symphony. Each universe plays its own tempo, its own rhythm, its own version of time, or no rhythm at all. Some are fast, some slow, some silent. Together they form something bigger than the sum of their parts, a timeless harmony that doesn't need a conductor. Maybe our universe's timeline is just one verse in an infinite song, each universe entering at its own moment, if moment even applies. And while we can never hear the full composition, perhaps it's enough to know that somewhere beyond our own ticking clocks, the music of existence never stops. It simply plays forever, unsynchronized, unending, and timeless. Every story needs an ending, even time's story, or so it seems. If time truly had a beginning, then it's only natural to ask, could it also have an end? Could there come a day when the cosmic clock simply stops ticking, not because it's broken, but because there's nothing left for it to measure? Physicists have dared to explore that chilling possibility that one day the universe could become so vast, so cold, and so empty that time itself runs out of things to do. It wouldn't stop dramatically. It would fade, dissolve, and eventually fall silent. Imagine the credits of reality rolling forever, long after the music has stopped. To understand how time could die, we first have to consider what keeps it alive. Time, in the simplest sense, is a record of change. Galaxies collide, stars ignite, atoms decay, and in that ceaseless rearrangement, we find the passage of moments. But what happens when change itself grinds to a halt? When the universe has expanded so far that every source of energy, motion, and transformation has been spent? At that point, time might not flow anymore, because there would be nothing left to flow through. Cosmologists have a name for this chilling future: the heat death of the universe. It's not as fiery as it sounds. In fact, it's the opposite. It's the coldest, loneliest, quietest fate imaginable. According to this scenario, the universe keeps expanding until all stars burn out, all black holes evaporate, and all matter disintegrates into a thin, ghostly soup of particles, entropy. The relentless drive toward disorder reaches its maximum. There's no energy gradient left, no imbalance to exploit. In that final stillness, nothing moves, nothing happens, nothing changes. Time, stripped of its purpose, simply ceases to matter. In that sense, time's death wouldn't be a cosmic explosion. It would be a cosmic sigh. It's not that clocks stop working. It's that the concept of working loses meaning. You can't measure intervals in a world where nothing transitions between states. Without change, there are no moments, only an eternal after. But heat death is only one possible fate. Other theories paint time's ending with different brushstrokes. One contender is the Big Rip, a scenario born from the mysterious force known as dark energy, the invisible pressure driving the universe's accelerating expansion. If dark energy keeps gaining strength, the expansion will speed up so violently that galaxies, stars, planets, and even atoms will be torn apart. The fabric of space-time itself would stretch until it unravels. Time wouldn't stop in a gentle fade. It would shatter, as the very structure that defines before and after disintegrates into chaos. The arrow of time would have nothing left to point to. A slightly kinder vision of time's end is the Big Freeze, a slower, quieter version of entropy's victory. The universe keeps expanding, but instead of ripping apart, it simply grows colder and emptier. Stars die, galaxies drift too far apart to see one another, and cosmic background radiation fades into darkness. Eventually, the universe becomes a vast black canvas, punctuated by nothing. It's like the final scene of existence stretched across infinity, static, silent, irreversible. Time still exists, technically, but it loses all practical meaning. When there's no event to mark its passage, time becomes indistinguishable from eternity. And then there's the big crunch, the most poetic of all possible endings, a cosmic rewind. In this scenario, gravity eventually overpowers expansion, and the universe collapses back in on itself. Galaxies fall together, stars collide, and time literally runs backward in some equations as everything converges into one infinitely dense point, the mirror image of the Big Bang. If the universe were to bounce back from that collapse into a new expansion, time could, in theory, be reborn, a phoenix rising from the ashes of itself. Some cosmologists even imagine that this process has happened countless times already, time dying, restarting, and dying again in an infinite rhythm of renewal. But not all endings are grand or violent. Some physicists suspect that time might not end out there in space, but in here, in perception itself. If time is not a fundamental feature of the universe, but an emergent phenomenon, as many theories suggest, then maybe time disappears when complexity fades. Once the universe loses its structures, its patterns, its observers, and its energy exchanges, the mechanisms that generate before and after would vanish too. In that sense, the end of time isn't just physical, it's existential. When the universe no longer contains minds capable of noticing change, time has no audience left to perform for. That brings us to one of the most haunting thoughts in cosmology. Maybe time doesn't end, it just stops mattering. Perhaps it continues indefinitely, but with no events to fill it, no clocks to count it, no consciousness to feel it. Infinite, meaningless duration. A still eternity stretching onward, with nothing to distinguish one instant from another. You could call it forever, but it would be a forever without memory, motion, or meaning. It's both terrifying and oddly peaceful to imagine the universe's last moment, if moment even applies. A place where everything that could happen has already happened. Every light has burned out, every atom has found rest, every equation has settled into balance. The cosmic story ends not with destruction, but with completion. It's not time ending, it's time finishing. Yet even this quiet death might not be permanent. Some speculative models propose that quantum fluctuations, the same restless jitters that might have sparked our universe, could stir again in the void. From the ashes of one timeless eternity, a new burst of space-time might bloom, igniting a fresh timeline with its own rules, constants, and possibilities. If that's true, then time's death is never final. It's just the universe pausing between verses. So, if time can be born, maybe it can die. But maybe death is the wrong word. Time doesn't vanish. It transforms. It slows, stretches, fragments, or fades, but it never truly disappears. Even in the silence of a heat-dead cosmos, the potential for another beginning may be sleeping quietly, waiting for a fluctuation to whisper, "Let there be when." And in that whisper the universe will stir again, and time, like a song restarting after an infinite pause, will find its rhythm once more. Try for a moment to imagine nothing, not empty space, not darkness, nothing. No light, no matter, no sound, and crucially, no time. The mind instinctively rebels. It wants to slip a little before into that nothingness, to picture it as a prelude to something else. But in doing so, we've already broken the rule. The very act of imagining before presumes time exists. It's like trying to think of a color beyond color, or to hear a silence louder than sound. The question itself, what came before time, folds in on itself. Maybe the real answer is that there was never a before to begin with. Stephen Hawking once said that asking what happened before time began is like asking what's north of the North Pole. It's not that the question is stupid, it's that the question stops applying once you reach the point where it no longer makes sense. North ceases to exist once you've arrived at the pole. Likewise, before ceases to exist once you've arrived at the origin of time. It's not an edge, not a wall, not even a boundary. It's the limit of a concept we created to describe something far too vast for our linear minds to handle. Throughout human history, we've treated time as the great ruler of reality, the invisible thread stitching cause to effect, birth to death, creation to decay. It gives structure to chaos and order to experience. But maybe we've mistaken the thread for the tapestry. Perhaps time isn't the framework of the universe, but a language we invented to describe change. It's how we count the transformations of something that has always existed in some form. The universe may not be older than time. It may be beyond it, existing in a way our time-bound minds can only glimpse through hints and metaphors. If we step back far enough, time begins to look less like an objective feature of reality and more like a convenient translation, our way of narrating a story that doesn't actually unfold. The universe may not be a movie rolling through frames, but a completed film reel, every scene existing simultaneously. To us, it feels like movement. To the universe, it's all one seamless whole. Past and future are just different coordinates in an already finished structure, and what we call the present is simply the slice of that structure our consciousness happens to be focused on. From this vantage, before and after lose their teeth. The universe isn't something that began, it's something that is. Timelessness doesn't mean stagnation, it means completeness. The cosmos doesn't need to evolve through time any more than a mountain needs to climb itself. What we experience as the passing of moments might just be our brains, which can only process one snapshot of the infinite at a time, walking through the gallery of existence and mistaking our movement for time's. It's almost comical how deeply we're wired for time. We think in cause and effect, storylines, sequences. Even when we try to imagine eternity, we tend to picture it as a really long stretch of time, an endless road instead of a roadless expanse. But if the universe truly transcends time, then eternity isn't long. It's now, always now, forever now. The universe, in that sense, isn't aging or evolving. It's simply revealing itself to us one frame at a time, like a cosmic flip book that never runs out of pages. This idea doesn't rob life of meaning, it deepens it. If everything exists simultaneously, then every moment we live, every breath, every spark of consciousness is permanently etched into the structure of existence. Nothing is truly lost, not even the past. Every laugh, every sorrow, every fleeting moment of wonder still exists somewhere in the eternal geometry of being. We move through them like travelers, walking through rooms in a house that's already built, unable to see the whole architecture, but living in each chamber as if it were the only one. And if time is simply how we perceive change, then maybe what we call beginning and ending are just differences in perspective. The birth of a star and the death of a civilization could both be static features of the same timeless whole. We see them as separate only because we experience them sequentially. The universe might not have started at the Big Bang. It might be the Big Bang, frozen in an eternal act of expansion, a single, infinite gesture stretching forever outward. If that sounds abstract, it's because language itself is trapped inside time. Words like before, after, always, and never are the scaffolding of temporal thinking. They crumble when we try to build them around something timeless. Maybe that's why our greatest scientists, poets, and philosophers often resort to paradox when speaking of the ultimate. The end is where we begin. All is motion, yet nothing moves. These aren't contradictions. They're our best attempts to describe the indescribable, to point toward a reality that doesn't fit inside clocks or calendars. So perhaps the universe isn't older than time. It's simply different from what we imagine. It doesn't wait for time, and it doesn't need to. Time is a lens through which we perceive the shifting patterns of something that, at its deepest level, never shifts at all. The eternal isn't something far away. It's the stillness behind every heartbeat, the quiet between every tick of the clock. And maybe that's the secret hidden in plain sight. Time was never the master of the universe. It was our translation of it. We invented it to give shape to the shapeless, to make sense of the infinite. Asking what came before time is like asking what came before existence. It assumes there was a gap, a pause, a moment waiting for its cue. But perhaps existence didn't wait for anything. Perhaps it's been here all along, not moving forward or backward, just being, calm, complete, and unbothered by the clocks we build to understand it. If so, then the story of time isn't a story at all. It's a reflection, a rhythm, a mirage our minds create to walk through eternity one thought at a time. And when the last clock stops ticking, the universe won't notice. It will simply continue to be, timeless, whole, and still humming softly with the quiet truth it's been whispering since forever. There was never a before. There is only this, always this, and it has never truly begun.